In this lesson, we're going to be learning about normal distribution. So far, we have looked at two different kinds of graphs. These two you can see here. One is the number of doctorates earned by minorities, and the second is the value of the sample proportion. How can we compare these two curves with what we've learned so far? What we've learned from Chapter 13 is hopefully when you see this data, you would call this skewed data. And which way is it skewed? Well, the skewness is going towards the right, so we would call this right skewed or skewed right. And then this second graph, you can see they have the bell-shaped curve drawn here, so we're going to call this data symmetrical. Also, we would call that bell-shaped. Now, depending on what kind of graph you have, if your distribution is normal or not, actually makes a big difference in how you use your statistics. In skewed data, we have certain things that are better to use than others, and in symmetric data, the same thing would apply. The one thing we're going to talk a lot about is how in symmetric data, our mean and median tend to be in the same spot. So if this was perfectly symmetrical, our mean and our median would be equal. When they're not perfectly symmetrical but just look symmetrical like this does, our mean and median are very close together, so they're approximately the same. They'd be very close numbers. If you remember from Chapter 13, when we have skewness, our mean gets pulled towards the skew. So if our median was here, our mean would be to the right. This is just an estimate, of course. And so this would be our mean. It gets pulled to the right because that's where our skewness is. And then our median would be to the left. So that's really all we can say about these graphs based on what we've learned so far. When we're describing distributions, so if we're talking about left skewed, right skewed, the first thing we do is plot the data. So we want to look at a picture of the data. A histogram is an excellent way to do that. A box plot also works. And then we're going to look for patterns. So the things we look for are shape, center, spread, and outliers. If you're taking AP Stats, we will talk a lot about SOCs. In fact, all of you, when you come to my room tomorrow, you'll see that on the board I have SOCs, those letters, in bright orange letters as magnets on my whiteboard. And that's to remember that you're going to use shape, center, spread, and outliers. So the word SOCs, outliers, would fit right here. Just so it can make a little word that you can remember. So that's what we look for. We'll talk about those things when we talk about graphs. And then we either choose a 5-number summary. That's what we choose for skewed data. So any data that's skewed, the 5-number summary is our best choice. Or if we have symmetric data, we're going to use the mean and the standard deviation to describe it. And we should pick the right one based on what kind of data we have. So you want to see the picture first. We check to see, number 4, you check to see if the overall pattern of a large number of observations is so regular that it can be described by a smooth curve. What we tend to notice, and you'll learn this more if you continue to study statistics a little bit more, but the more observations you have, or the more data values, the closer to normal your data becomes. For instance, if I took just our grades in this class, and I wanted to graph them on a histogram, let's say, by A, B, C, D, F. This class might have a bunch of A's and not very many F's and D's, so we might have right skewed data. But if you take every class from every teacher in our school, we should probably have a bell-shaped or normal distribution. A lot of kids are on the average of a C, and then there's some outliers, some that are A's and B's and some that are D's and F's. And so you're looking for that bell-shaped curve. And that's actually kind of a debate in education sometimes, is if your class should have a bell-shaped curve or not. Are we hoping to be the normal curve, or do we want some skewness in our data? These graphs here now, these are just graphs, and you can describe them any way you want, right? They represent either births by month, the number of sodas consumed in a week, or the money spent on textbooks in one semester. So we're going to try to match the situation to the graph. We don't have numbers here, but what we can assume always is that these go from least to greatest, right? We've never seen one that doesn't. So like if this is a 0, this is more. Whatever. Let's pick a number, like 100. It's not. On the bottom here, this would be like January, or I'm totally giving you answers here. Start over. This would be like 0 to 100. It goes least to greatest, 0 to 100. So which of these match each of them? So for this one, this is definitely right skewed, isn't it? This one, I don't think I describe as normal because they're all the same. So this one has the same amount every single time. So we don't have a name for this. I'm just going to say same, all same. And then this one we describe as symmetric. So of these, the first one is births by month. If I looked at the whole U.S. population, so not just our class, because I want a big sample. If I looked at our class, we might have some skewness or some differences. But when you start to look at the whole nation or the whole world, births by month, really, is there more probability to be born in some months than others? Maybe in certain countries, just because of summer versus winter, sometimes people would argue. But overall, really, shouldn't there be the same number of births every month? Or the same people who have a birthday in those months if we looked at the whole population? Probably about the same people have a January versus February birthday. And so this one right here, which I kind of cheated earlier and actually I told you, this is listing like January, February, March, April. They'd be about the same. So this one is our births graph. Now the other graph is either number of sodas or money spent on textbooks. Do you think most kids have just a few sodas, like 0 or 1 sodas, and then 2, 3, 4, 5, and then it gets, not as many people have 5 sodas as have, let's say, 1 soda? Or do you think that this would be money on textbooks? So most kids spend very little on textbooks, like $0 to $100. Well, let's even say 25. Let's go by 25s. $0 to $25 on textbooks, and then some spend 50, some spend 75, very few spend 100. So you have to kind of decide which of these data makes more sense to be right skewed. Hopefully when you see that, you're going to realize that the soda would make most sense. I think most kids would have either 0 cans of soda a day, so like if you count how many kids, this is the number of kids, so 5, 10, 15, 20, let's say we surveyed our school. 20 kids said they had 0 sodas. 1 soda. 20 kids said they had 1 soda. And then 2 sodas. 10 kids had 2 sodas a day. Or in a week, excuse me. 3 sodas. 5 kids said they had 3 sodas a week. Does that make sense? Most kids aren't going to have 10 or 12 or whatever this number ends up being sodas in a week. That's just not going to happen. It's right skewed. So this would be our sodas. So then lastly, this one obviously has to be our textbooks, but let's explain why. Textbooks probably have an average price. Let's say in a semester kids spend $200 on textbooks in college. Some kids are going to spend 100, 150, 75, whatever that wants to be, and some kids are going to spend like $400 on textbooks. But most kids will spend the average price. The average, and then they'll go up or go down. So that's where you get your symmetric data. Most kids hit the average, then there's a few below. And hopefully you'll be able to look at some graphs like that and be able to pick out which one would match based on these right here. The median of a density curve is the point that divides the areas under the curve in half. So when we have a symmetric graph, it should be right here in the middle, right? Divides it in half. There should be this many, 50% here and 50% there. And my graph's a little off, so you have to be more perfect. If we have skewed data, let's say the median's here, 50% here, 50% here, because there's fewer here and this is a little smaller, let's say. So we'll look at that. The mean, however, is the balance point. So the mean is different. In a symmetric graph, the mean is in the same spot as the median. It's right in the middle. It keeps it balanced. So there's an equal number of values on this side and an equal number of values on this side as far as how much they're worth or their amount. Here is a little bit of a better picture. The mean and median in symmetrical data is the same. We've talked about that before. And in skewed data, the mean is pulled towards the skew. So the average is pulled towards that skewness, because think about it. When we did that Twins baseball one and we had some players who made $15 million, they really skewed our mean, didn't they? That when most people make under $1 million a year, that one $15 million person, they really make it seem like those people are doing really well. They make the average for everyone else go up. So that's why we would choose not to use mean when we're describing Twins baseball. In skewed data here, you can see that the balance point is where the mean is. So where does this make it balanced? That's what you're thinking of for the balance point. This is a little bit misleading because this would not be the balance point, since this is if we're looking here in the balance point, since we're right skewed, and if this is our mean would never be to the left. So the balance point's got to be somewhere right here. that kind of weighs out that data. Definitely with skewed data, it's not here. So this is what we're looking for when we talk about the balance point. The median and mean are the same for symmetric data, which we've talked about. The mean of skewed data is pulled in the direction of the skew. That's also something that we've talked about. So you can pause the video and copy those down if you like. For each graph below now, you see you have 4 graphs down there. It says, sketch a smooth curve that describes the situation, or the distribution. Mark your best guess for mean and median, and then decide if it'd be better to describe the distribution with the mean and standard deviation or a 5-number summary. So remember, 5-number summary is better for skewed data. Mean and standard deviation is better for symmetric data. So that's what we're looking for. So the first thing is to do this curve. Oh, C and D are way down there. So here's my curve. I'm going to do it for all these at once. I think it's best to just do all 4. We're doing those curves. So A and B I think are the easiest because they definitely have different ones. So we did the smooth curve for all, and then we're going to make our best guess for median and mean. Well, A I would say is skewed data, right? Doesn't that look like skewed data? So if I put our median, let's say right here, and draw that down and actually label it median, where would my mean have to go? My mean has to go in the direction of the skew. Anything you put to the right is going to be a right answer. We aren't actually calculating this out, and mine might not be right. I am just estimating here, aren't I? In fact, I know it's not right. But I'm just kind of estimating. I'm just guessing where it is based on what they told me. As long as you put the mean to the right of the median, you're good to go on this one. In B, I would describe this data as symmetric. So I'm going to put my mean and median in the same spot. So that's my median and my mean. Now, it's not perfectly symmetric, so I do know it'd be a little bit off, but this data is, pretty close. So putting it in the same spot is fine. If you chose to go really with this graph, the mean or median would be a little bit off to the left or to the right. Just a little bit, though. You wouldn't be able to tell a big difference. But for us estimating, putting them in the same spot is best for symmetric. C. This data is pretty symmetrical too, right? They're all kind of the same. This is like our months one, our having births by month. This would be a good graph for births by month. And so I'm going to put the mean and median in the same spot. Median and the mean. And for this last one, I would say that it's a little bit right skewed, right? See that kind of tailing off there? But not too much. So if I put the median here, I'm going to put the mean fairly close to it because it's not super skewed. And I feel like we need to just show, we haven't really had one that's left skewed, so I'm just going to draw one quick. If this was the one, I just want to point out, the median would be here, and the mean would be to the left. I just want to make sure you realize it can go the other way, because we've had a lot of right skewed ones in this graph. The last thing then is to decide if we should use the 5-number summary, or the mean and standard deviation. Well, with this first graph, A, this is skewed data, so we're going to say 5-number summary is best because it's skewed. In B, it's symmetric data, so we would say the mean and standard deviation would be best. In C, again, we kind of picked that to be symmetric, didn't we? So mean and standard deviation. And then in D, this is skewed data, so we'll say the 5-number summary. So it's important to remember 5-number summary is what we use for skewed. Mean and standard deviation would be used for symmetrical, normal, bell-shaped data. Normal curves is what we're going to talk a lot about this chapter. And so to define them a little bit, normal curves, what we say normal, is symmetric, bell-shaped curve. The mean is defined as the center of the curve, so the mean will be in the center because it's normal. Remember how we said the median and mean would be in the same spot? And the standard deviation affects the width of the curve. So in both of these, the mean is in the middle. Notice that. The standard deviation is how far away something is from the mean. So see, if this would be considered a low standard deviation here. This graph, which is flatter, so the flatter the graph, the higher the standard deviation. These are further away from the mean. So if you have a really high hill, you have not a lot of variation. Not a lot of change happening here. Everyone's getting about the same thing. Here, you have a lot of variation. There's a lot of different levels. And so that makes a big difference what your standard deviation is, even though we might have the same mean. Our average might be the same, but if your standard deviation is higher, like it is in this one, you have more variation in your data. You are going to do what's an activity tomorrow in class. We're going to do a normal distribution activity. We're going to measure heights and put them all on a chart. So we will do that in class tomorrow, and then we'll answer some questions together. So we'll have a little bit of a lesson in class, and then you'll be able to do your worksheet and things that go with this. So if you have any questions, make sure you let me know tomorrow in class.